Good day everyone, I'm Francisco Verga with my partner Denese Namia, and we're here to explain our assembly language program titled Multifunction Number Calculator. This program demonstrates parameter passing, procedures, and modular programming in assembly. It performs several number-related operations, the LCM, GCF, factors, multiples, and prime factorization. So let's start with the data section, where we declare all the constant strings and message templates used in the program. This greet is for the welcome message, menu for the list of options, and rchase and rrange for error messages, and output templates like out LCM, out GCF, out factors, out multiples, and out prime fact. We also declare string buffers, the buff1, buff2, and buff3 for storing computed results such as factors and multiples. In the BSCS section, we reserve memory for variables. Choice stores the user-selected option. N1, N2, and N3 store the 3-input number, and temporary registers A, B, and R are used for calculations. The text section contains the main logic of the program. The label main serves as the entry point. It displays the greeting message using printf, and then enters the menu loop where using selects and operations. The program checks the user choice using a series of CMP and JE instructions. If the choice is 1, it goes to do LCM. If 2, it goes to do GCF. If 3, do factors. If 4, do multiples. If 5, do prime factorizations. And if 0, it exits. If an invalid number is entered, it prints an error message and shows the menu again. For every operations, the program asks for 3 2-digit numbers. Each value is validated to ensure it's within the range of 1 to 99. Now, first look at the structure of one section. The code starts with the label show LCM header. This marks the beginning of the subroutine that will display the LCM header. Next, we have push HDR LCM. Here, the program pushes the memory address of the string HDR LCM onto stack. This string contains the header text we want to print on the screen. Then call printf. This instruction calls the printf function from the library which actually print headers on the screen. After calling printf, the stack still contains the parameter we pushed earlier, so we clean up using add-asp4. This removes the last item from the stack, making sure memory stays properly aligned. Finally, we have gmp do LCM. This jumps directly to the routine that performs the LCM operations. This means once the header is displayed, the program continues by executing the LCM computation code. The same patterns applies to all the other sections. The do LCM routine starts by asking the user to input 3 numbers using printf and scanf. It validates each number to ensure it's between 1 and 99. If any numbers is invalid, it jumps to LCM error and display an error message. This is passed by value since the procedure receives copies or data. The do GCF section is also a pass by value. It prompts the user checks that all numbers are within range and then pushes the actual values of the 3 numbers onto the stack. Next is do factors. This part is similar in structure. It prompts the user, validates the input, and if everything is valid, it calls factors. This is by reference, meaning the procedure can access the modify the original data stored in memory. The do multiples is also a pass by reference. The do prime fact section works the same way using pass by reference. The do exit section is simple. It just displays a thank you message and ends the program using the ret instructions. So let's move now to procedure. The procedure of LCM, it computes the least common multiple using Euclidean algorithm. And for procedure for GCF, this procedure finds the greatest common factor using repeated divisions until the remainder becomes 0. The procedure's factor, it calls a helper function build factors string will loops through from 1 up to given number. For procedure multiple, this generates the first 10 multiples of number. It multiples the base number by values 1 through to appending each result to a buffer. For procedure prime fact, this one builds a string of prime factors separated by the X symbol. It divides the number by 2, 3, 5, repeatedly until the value becomes 1. Next is we're going to explain how to run this assembly language program. You have to generate the object file first. So just prompt nasum-f win32, the file name -o, and the object file. Next is to link the generated object file. Just prompt gcc, the object file -o, then the executable file. This to produce the final executable file. To run the compiled assembly program, just prompt the executable file.
So let's start with option 1, the LCM. The users enter 3 numbers, in this example 75, 30, and 50. The program computes the least common multiple using a pass by value subroutine and displays the result, which is 150. Next, we'll choose option 2 for the greatest common factor. Here, the user first enters invalid numbers. One of them is negative, so the program shows an error message reminding the users to enter values only between 1 and 99. After entering valid inputs, the 30, 66, and 99, the program correctly computes the GCF, which is 3. For option 3, the program displays all the factors of each entered number. For example, for 20, 33, and 42. It lists all the numbers that divide each of them exactly. So next, option 4 shows the multiples of each number after the 10th multiple. This demonstrates another modular procedure using pass by reference to handle the data efficiently. So option 5 performs prime factorizations, breaking each number down into its prime factors. For example, 60 becomes 2 times 2 times 3 times 5. 72 becomes 2 times 2 times 2 times 3 times 3. And 91 becomes 7 times 13. This again uses modular programming where each operation is handled by its own procedure. So if the user enters a value that's not in the menu, like 6, the program displays an error message and returns to the main menu. Finally, choosing exits program. Choosing 0 exits the program and displays a thank you message. That's an end of our demonstrations. So in summary, our multifunction number calculator showcases modular programming in assembly language, combining fast by value, pass by reference, and user input validation. So that's all. Thank you for watching.